Okay, dear students, let us see what is there in this question now. When 40 kilojoule of energy is transferred to a quantity of liquid substance, so the quantity is not given, its temperature increases by 20 Kelvin. When 600 kilojoule of energy is transferred to the same quantity of the liquid at its boiling temperature, it vaporizes completely at constant temperature. So the phase transformation is taking place. What is the ratio of specific latent heat of vaporization and specific heat capacity of the liquid for that substance? Okay, fine. So my dear students, as we all know that whenever the heat is supplied to a substance, it can be used in two manners. Like the first kind of heat is known as sensible heating. Now, what is this sensible heating? Sensible heat. Sensible heat is the heat which is when absorbed by a liquid, it increases the temperature of the liquid. So in this question, we are going to compare these two heats, that is sensible heat and the second one is the latent heat. So in sensible heat, we use the formula Q is equal to mc delta T, where delta T is the temperature, m is the mass of the substance, C is the specific heat of the substance, Q is the heat provided. Now, point number two, the second kind of heat is known as latent heat. And this is a heat, like the word latent means hidden. So this is a heat which is absorbed by the substance and it is just hidden because the temperature of the substance is not increasing. And why the temperature is not increasing? Because the substance is now changing the phase from liquid to vapor or from solid to liquid. Accordingly, it is known as like latent heat of vaporization or latent heat of fusion. For this, we use the formula Q is equal to M into L. So this is the heat that we have to supply. And in both of these cases, the heat is given to us. In the first case, 40 kilojoule is given. So there is sensible heat. And 600 kilojoule is given for the phase transformation. So it is definitely talking about the heat that was given for phase transformation. So accordingly, the first equation becomes Q is equal to mc delta T, and this Q is given as 40K, M is not known, C is not known, and delta T is given as 20 Kelvin. Now in second case, Q is equal to M into L, and heat given is 600K is equal to M, mass is unknown, and the latent heat is also not known. So now what we want is the ratio of latent heat to the heat capacity of the liquid. So we will divide this thing. This will be taken as like equation number one. This will be equation number two. And dividing the first equation by second, what we get is M into L divided by mc delta T is equal to 600K divided by 40K. So obviously the 1000 gets cancelled out and the 0 will be cancelling out. M and M gets cancelled out. We are just remaining L by C. So this K and K gets cancelled. This and this I can cancel it less 2. So this will be taken as 300. So L by C comes out to be 300. And the unit will be, this will be delta T. So this 20 will multiply there. So it will be Kelvin. So 300 Kelvin, the answer for this question will be D. So this is how we do it, my dear students. Now, there is one more point I would like to specify here. The specific heat capacity. So it should not be confused with heat capacity. There are two things like heat capacity. So this is defined for a body and heat capacity is equal to the product of M and C. And C is known as the specific heat or specific heat capacity. One is the same thing, and this relates with C, and that is this C we are talking about. Specific word means that you are dividing something by mass. When you divide something by mass, you call it specific. Okay, so this is how we do it generally. It's not like every time we do that, but generally it is correct that whenever we say specific, we divide the equation by mass. So we are only talking about C. Okay, dear students, this is Professor Varun. Please subscribe to the YouTube channel. All the best. Okay, dear students, let us see how to do this question. A quantity of 2 mole of the ideal gas is maintained at a temperature of 127 degrees centigrade in a container of volume 0.083 meter cube. What is the pressure of the gas? Okay, so I think like it's a simple question. That is, we have to directly apply the ideal gas equation here because every else thing is given. So what is the ideal gas equation? PV is equal to nRT, and pressure is what we need to find. Volume is given as 0.083. Number of mole is 2. Gas constant will be used in SI units, 8.314, because everything is in SI. And temperature is given as 127 degrees centigrade. So we have to convert it into Kelvin by adding 273 into it. So this is the equation in front of you, and we just need to solve this thing now. So going to the calculator now, 127 plus 273 will be 400 here. So 400 multiplied by 2 multiplied by 8.314, it is going to be divided by 0.083, and so there we are. The pressure is coming out to be 80134.9 approximately. That can be taken as 80K. Yes, so D is going to be our answer for this question. Fairly simple question, only one equation will be used in this question. All the best. Bye. Okay, dear students, let us see how to do this question. A sample of oxygen gas with a volume of 3 meter cube is at 100 degrees centigrade. The gas is heated so that it expands at constant pressure. Okay, so the gas is there in the container and which is at state number 1, and now it follows a process, and the process is constant pressure, which is given a special name also, and that is known as isobaric process. Now, what happens in isobaric process is that pressure does not change for the gas. Now, the final volume is 6 meter cube. And what is the final temperature of the gas? Okay, how to do this thing now? See, ideal gas always follow the ideal gas equation, whichever process it is, like it is isobaric, isothermal, adiabatic, or isochoric, or whatever process it be. But ideal gas will follow the ideal gas equation. It means that PV is equal to nRT will always be followed. So we can always say that at the first state, like for state 1, it should be P V1 is equal to nRT1, and for the state 2 it will be PV2 is equal to nRT2. And now what we do is we just divide these two equations by each other. So PV1 divided by PV2 is equal to nRT1 divided by nRT2. And all these things will get cancelled out because they are not changing. So we reach to this equation, which is quite simple to solve. This is the equation where we are now going to substitute the values. So for one, it was 3 meter cube was the volume in 100 degrees centigrade. So on substituting, it will be 3 divided by 6, because now final volume is 6. The initial temperature, now temperature has to be taken in absolute terms always. You see, in this equation, there is N, which is number of mole, isn't written in small letters. Every other thing is written in capital letters. Why? Because they are always taken in the absolute terms. So when we take in absolute terms, we write those things in capital letters. So this temperature has to be in Kelvin. So it will be 273 plus 100 divided by T. And now we need to find T here. So this will be 2 and 2 will be multiplied here. So our answer will be 373 multiplied by 2, that is 746. So in Kelvin, our second temperature will be 746 Kelvin. Now minus 273, the answer will be 473 degrees centigrade. Now we are moving to our solutions, our options given here. B is the nearest most option, that is 470 degrees centigrade. So this is how we do this question. And generally, what is the mistake that students do? They do a mistake here only. Instead of Kelvin, they make the calculations in degrees Celsius only, and that is why they would be getting some other answer. But this is not what we are going to do. Okay. So, my dear students, this is Professor Varun. Please subscribe to the YouTube channel. All the best. Bye. Okay, dear student, let us see how to do this question now. Two identical containers, X and Y. It means volume will be taken same for both of them. Each contains an ideal gas. X has n molecules of the gas at absolute temperature T, and Y has 3 n molecules at the temperature of T by 2. What is the ratio of their pressure? Okay, so first of all, we are now going to use the ideal gas equation here. So in case of X, like for X, it will be Px, and the volume is same in both of the cases. So I'm just writing it V. Now, PV is equal to nRT. And what is N? N is number of moles. And how do you find number of moles? Number of moles is found by dividing the total number of molecules divided by Avogadro's number. So small n can be written as n divided by Avogadro number, that is 6.023 in 10 by 23. Okay. Now this into R into T, because T is the temperature at which the box X is maintained. And now similarly for Y, I will write it as Py V is equal to, now the number of molecules are 3 times, now it's 3n. So 3n divided by Avogadro's number multiplied by R universal gas constant, and the temperature that is maintained is T by 2. Now, we need to find the ratio of Py by Tx. So it means we have to divide the equation number 2 by equation number 1. So Py into V divided by Px into V. And we can just divide these two equations by writing. If you face any problem with mathematics, what you can do is you can find a constant term and you can replace it later. Okay, so you can divide it, and okay, I tell you, okay, I'll do like that only. So this will be 3n divided by na RT by 2 multiply by. Now, this was the second equation and it was supposed to divide it. So it means we need to multiply with the reciprocal of this. So the reciprocal is Na will become the numerator, N into R into T. And all these things will get cancelled out and it will be 3 by 2. And V is also getting cancelled. So we get Py divided by Px is equal to 3 by 2, and C should be the answer for this. This is how we have to do it. And the substitution process that I was talking about, that will be done like this. You can take this thing common, like n divided by this R into T, and you can compare it here. So you can completely substitute this and only 3 and 2 will be left. So it will be Py into V will be 3 by 2 multiplied by, when you replace this complete term here instead of this, it will become Px into V. V and V gets cancelled out and you get the same answer. That is Py by Px is equal to 3 by 2. So mathematics depends upon you, like what methods for from the algebra that you want to use. But otherwise, you are going to get the same answer here. Py by Px equal to 3 by 2. Okay, dear students, this is Professor Varun. Please subscribe to the YouTube channel and do share the YouTube channel with all your friends. All the best. Bye. Okay, dear students, let us see what is there in this question. Okay, a piece of metal at a temperature of 100 degrees C is dropped into an equal mass of water at the temperature of 15 degrees C in a container of negligible mass. So there are three things, like one is container, but the mass of the container is neglected. So container is not getting heat, it's not getting heated. So we are going to neglect it. And yes, there is water, and we can just assume that the mass of water is m, and the mass of the piece of metal can also be taken as m. The specific heat of water is 4 times that of metal. So specific heat of water is 4 times specific heat of metal. What is the final temperature of the mixture? So my dear students, this topic comes from a branch in physics that is known as calorimetry. calorimetry, and the principle for the calorimetry is the heat lost by the hot body is equal to heat gained by the colder body. Okay, so here metal piece is hotter and water is cold. So let us say the equilibrium temperature which was achieved is capital T. So it means that the metal piece has reduced its temperature from 100 to T, so it lost some heat, and the water has increased its temperature from 15 to T. It means it has gained some heat. So the heat lost is equal to heat gained. So first of all, I can write heat lost will be equal to, let us say for the metal piece mass is m and specific heat of metal heat into delta T. So earlier it was 100, now it is T, which is lesser than 100. So we have to write 100 minus T. Now you will say that, sir, why have we taken the degree C temperature here, but why are not we converting this thing into Kelvin? And the reason is that the size of the degree for 1 degree centigrade and the Kelvin is the same. So that is why whenever we are concerned with delta T, so either you take C degree or you take Kelvin, one is the same thing. Because in delta T, there is no difference. Like there are 100 divisions in 100 degree to 0 degree for Celsius grade and 100 divisions for the boiling point and the melting point for water in the case of Kelvin also. So the size of degree is the same. That is why delta T will be, you can choose in degree C also. Now, what is the heat gained? So heat gained will be M into Cw and T should be more than 15. So just to keep it positive, we are doing T minus 15 now. So these two things must be equal to each other. So M into Cm 100 minus T will be equal to M into Cw. Now Cw is given as 4 times the specific heat of metal. So I'm just writing it Cm T minus 15 MCM 100 minus T. So this and this gets cancelled out. So we are left with this. 5T is equal to 160. So it's 160 divided by 532. It means that the temperature now is 32 degree C. So we have got the answer in degree C only because we were using the centigrade scale and we were not putting the value in Kelvin. That is why. So here the answer will be T. So this is how we will solve this question, my dear students. So if you have any doubt in this topic further, you can ask me in the comment section. This is Professor Varun. Please subscribe to the YouTube channel. Also share the YouTube channel with all your friends. All the best. Bye. Okay, dear students, so what is happening in this question? Let us see. An ideal gas of constant mass is heated in a container of constant volume. What is the reason for the increase in pressure of the gas? Now, as we know that as given in KTG, that is kinetic theory of gases, whenever we increase the temperature of a gas, so what is it that is happening to the molecules of the gas? The molecules of the gas have more velocity, they have more kinetic energy, and that is why they are moving at a faster pace now. They're moving at higher velocity. Obviously, they will end up having more momentum. Now, when we talk about pressure, now what is pressure? The collision between the molecule and the wall is responsible for creating pressure. So it's collision between the molecule and the wall. Okay, and now if the temperature has increased, now it is moving at a higher velocity, it has higher momentum. So there it is, there is higher momentum change in each and every collision. It only means that there is more force on the wall due to the molecules because now more change in momentum is taking place. That is why we will say that the average force that is being exerted on the wall by the molecules when they are colliding with the wall, it increases, and due to that we will say that pressure increases on heating. Now let us read the options here. The average number of molecules per unit volume increases. Not at all. We are not increasing the number of molecules. Average force per impact at the container wall increases. Absolutely correct. B is the correct explanation. Let us go for C and D also. Molecules collide with each other more frequently. But yes, this is true. But if they're colliding with each other, that does not mean that they are creating pressure on a wall. Like pressure on a wall will be created by the collision of molecules with the wall. If they're colliding with each other, doesn't matter. But although this statement is true, the answer is not right. Molecules occupy a greater fractional volume of the container. Like this doesn't make any sense. Where, according to the assumptions in KTG, the volume occupied by the molecules is very, very tiny. I would say very small when it compares to the total volume of the chamber. So the volume occupied by the molecules actually is very small. That's the assumption in KTG. So C will also be wrong, D is also wrong, and hence B is the right answer. Okay, dear students, this is Professor Varun. Please subscribe to the YouTube channel and share the YouTube channel with all your friends. I'm putting so many questions there on YouTube. You can also join, like there are so many playlists. Okay, then all the best. Bye. Okay, dear students, so let us see what is there in this question now. Two flasks P and Q contain an ideal gas and are connected with a tube of negligible volume. This is very important condition compared to that of the flask. The volume of P is twice as that of Q. Now there are two chambers and they are containing the same gas. So the molecular mass is the same and all that, but the volumes are different. So this volume will be taken as 2V, here the volume is V. And we can just assume that the number of moles here is N2, number of mole here is N2, N1 and N2. Okay, and so the gases will first of all flow through the pipe into the two chambers, and then they will just settle down. And when will they settle down? When the exchange of the gas will be stopped, when the pressure in the two chambers become equal to each other. So without even telling this thing, we know that the pressure in both of the chamber has to be taken as same. Now what is about temperature? Now P is held at a temperature of 200 Kelvin. Okay, and Q is maintained at a temperature of 400 Kelvin. Fine. And we want to find the ratio of the mass of gas contained in P divided by mass of gas contained in Q. So how can we do that? So first of all, let us say we are going to apply ideal gas equation for the container P. So P is the pressure and 2V is the volume. PV is equal to nRT. So I'm just taking N1 as mole here. R is a universal gas constant and temperature is 200 Kelvin. Whenever they say ideal gas, the first thing that should come to your mind is ideal gas equation, and that's it. So we have taken this thing. Now for Q. Now for Q, the pressure will be taken as same because only then it will become stable, otherwise not. Volume is V and number of mole is N2R and the temperature is now 400. So clearly now what we can do is we can divide these two equations 1 and 2. So P into 2V divided by P into V is equal to N1 into R into 200 divided by N2 into R into 400. So R and R gets cancelled out, V and V gets cancelled out, P and P get cancelled out, and we can cancel 200 with this. It will be 2 here, so 2 will be cross multiplied. So this is what we have now. N2 divided by N1 is coming out to be 4 divided by 1. It means that the chamber P is containing 4 times the moles which are contained in the chamber Q. So obviously now you can see that number of mole can also be written as the weight or the mass of the gas divided by the molecular mass. This is how we find the number of moles of a gas, isn't it? Now we substitute this thing into N1 by N2 is equal to 4. So we get M1 divided by M divided by N2, which will become the reciprocal. So it will be M2 and M. So M and M gets cancelled out. Again, the ratio for M1 and M2 is coming out to be 4. So mass contained in P is 4 times. So it is 4 by 1. So our answer is C. This is how we do it. I have tried to be as clear as possible even for the mathematics that we are doing here. Okay, so even now, if you have some problem with the mole concept from chemistry or something, please mention that in the comment section. And this is Professor Varun. Please subscribe to the YouTube channel. All the best. Bye. Okay, dear students, let us see how are we going to do this question. An insulated tube is filled with large number n of lead spheres, each of mass m. Okay, so there are like this is a tube, and there are so many of the lead spheres that are packed there, and these are n number of spheres, and m is the individual mass. So the total mass can be taken as n multiplied by m. Now, the tube is inverted s times so that the spheres completely fall through an average distance of L each time. So it's like done like this, and each time all the spheres they're traveling the distance of L. And so s times they have inverted, like this is like 1, 2, 3, 4. So each time is calculated. So the temperature of the sphere is measured before and after the inversions. The resultant change in temperature is delta T. What is the specific heat capacity of the lead? Very good. So what is happening is we are inverting this thing like this, S times. And overall, these molecules, these spheres are falling, and some kind of energy is getting converted into another kind of energy. So we have to identify like which two energies are here related with each other. Energy cannot be created nor destroyed. Obviously, heat energy has come from something, from some other kind of form. What is that? That is gravitational potential energy. So what is the formula for the gravitational potential energy? M is the mass that has fallen through the height h. So what is the total mass? N into m is the total mass. G will be taken as gravity, and what is the total height for which the masses have fallen? Now in one reverse inversion, the distance covered is L. In second, it becomes L by 2, 2L, and in third, it becomes 3L, 4L, 5L, 6L. And it was inverted as time. So, what is the total height from which they have fallen? That can be taken as S into L, because S times it is traveling the distance L. This is the total potential energy now. And what is the formula for the heat that was absorbed? So, that is mc delta T. T can be taken in Kelvin or in absolute terms also. So you can write capital T as well as small t. Whenever we write small t, generally it is degree C, and when we write capital T, generally it is Kelvin. So now what is the mass? Mass will be N into M C into delta T. Now these two equations have to be equated with each other. Heat lost is equal to heat gained. Okay, energy lost, sorry. So we have this thing now. N into M G S L is equal to N into M C delta T. N into M gets cancelled out. We want to find C, that is specific heat capacity. So keeping C here, delta T is taken to the other side. It will be G S L divided by delta T is equal to C. So this is what we are getting. SGL divided by delta T. So now we have to see the options, and we will see which option is correct. SGL divided by delta T. I'm going to move this thing a little bit. And SGL by delta T, yes, B is the correct answer for this question. This is how we do this. I believe things should be pretty clear to you now, and this is a very good question, isn't it? Okay, so my dear students, this is Professor Varun. Please subscribe to the YouTube channel. Share the YouTube channel with all your friends. All the best. Bye. Okay, so let us see what is there in this question. Boiling water is heated in a 2 kilowatt electric kettle. The initial mass of the water is 0.4 kgs. Assume the specific latent heat of vaporization of the water to be 2 megajoule per kg. What is the time taken for all of the water to vaporize? Okay, so first of all, the temperature of the water is not given, but it is given that it is boiling. So we will safely assume that the temperature is 100 degrees centigrade already. So it means only and only the phase change is taking place. As I have told you earlier, the heating is divided into two parts. Like one is sensible heat. It is the heat which is used to raise the temperature, and the formula used is Q is equal to mc delta T. And the second one is the latent heat. So it is the heat which is actually hidden inside the substance. That is, it means there is no temperature change there. And the formula used here is Q is equal to m into L. So there is no term which talks about delta T or change in temperature. Now this question is specifically about the latent heat and the phase transformation. Fine. So, what will be the heat that is required? Specific latent heat is given. So, in this question, first of all, we will find like what is the heat that is required. So, mass is 0.4 kgs multiplied by the latent heat, that is 2 megajoule divided by kgs. I have written the units also just to make sure that everything fall in place. Kg and kgs are getting cancelled out, so we would be having 0.8 megajoule. So this much is the energy that is required to evaporate all of the water. Now the question is in how much time? So now we concentrate on the heating coil in the electric kettle. It is having the rating of 2 kilowatt. So the power. So the power can be taken as 2 kilowatt, that is 2 kilojoule per second. So we want to find the time. So definitely the time will be Q divided by P, and Q is 0.8 into mega. So now I'm just converting mega into 10 raised to powers. So it is 10 to the power 6, and we divide by 2 into 10 raised to power 3, that is kilo, and the answer will come in seconds. So this is how we do this. Let us see. This is 3, and we remove the decimal. This becomes a 4, and this becomes 100. So it's 400 second. So I think the time that will be taken to evaporate that much of the water in this kettle is 400 seconds. So our answer will be B. This is how we do this question. So my dear students, this is Professor Varun. Please subscribe to the YouTube channel. It will be highly beneficial for your preparation, and share the YouTube channel with all your friends also. All the best. Bye. Okay, dear students, let us see how are we going to do this. A gas storage tank of fixed volume V contains n molecules of an ideal gas at temperature T. The pressure at Kelvin temperature T is 20 megapascal. Sorry for that. N by 4 molecules are now removed, so 3 by 4 is left. The temperature is changed to 2T. What is the new pressure in the gas? So first of all, we are now talking about the ideal gas. So whenever we talk about ideal gas, the first thing that comes to our mind is ideal gas equation. So there are two cases. So I just write a case number 1. So PV is equal to nRT. Let us start filling the equation now. Let us say the pressure is, okay, pressure is given as 20 megapascal. So you can just write 20 megapascal here. And I'm writing the units also along with that. You may or may not. Now, V is the volume that is fixed. N, there are n number of molecules, so small n is number of moles. So how do you find number of moles? Total number of molecules divided by the Avogadro number, that is 6.023 into 10 power 23. So this we have done multiplied by universal gas constant, which is constant every time, and the temperature is taken as T. Now the second case is pressure, we don't know. The volume is kept constant because you can't change the chamber, but the number of molecules have been changed. N by 4 has been removed. So what are the number of molecules left? 3 by 4. So it's 3 by 4 into N divided by Na will be the number of moles now, into R into temperature is now double, that is 2T. Again, a similar kind of question that we have done these kind of questions earlier also. So there are two equations now. We just need to divide it, or you can create an expression out of it. You can replace it. One is the same thing. that can also be done, but anyways, it will be better if we divide these two equations. Now be very careful for the mathematics that we are going to do. Now when we divide these two equations, the left hand side of one equation is divided by left hand side of other, right hand side of another is divided by the right hand side. Okay, so I can just write 20 mega Pascal I have now removed, V divided by PV. Okay, so left hand side divided by left hand side, and this is N into R into T divided by N A. So this is this, and we can write it the other way also, don't get confused. So N R T divided by N A divided by this thing, so it will be 3 by 4 nRT divided by NA, and 2 will be extra here. So these two things, they are just getting cancelled out, and the it is getting reciprocal now. Be very careful for maths, okay? So I don't want you to get confused here. Like there are all kind of students, okay? So the denominator here is now multiplied in reciprocal. So the denominator becomes numerator, the numerator here becomes the denominator. So nRT, nRT, this and this gets cancelled out, this will be 2. So eventually it comes out to be 2 by 3, and V gets cancelled out. So P will be taken to the other side. It is 20 into 10 raised to power 6 divided by P, 2 by 3. Now this implies P is 3 by 2 times 20 megapascal. This is 10. So our answer is 30 megapascal. Only the maths is difficult, I would say, like if you feel like, otherwise it's not even difficult. Okay, if you have a little more practice of these kind of questions, this mathematics that we have done here, it comes out to be very easy then. Okay, so this is how we do this question. My dear students, this is Professor Varun. Please subscribe to the YouTube channel, and I'm uploading so many other questions also, you can refer to them. All the best. Bye. Okay, dear students, let us see what is there in this question. A fixed mass of the ideal gas is trapped in a cylinder of constant volume, and its temperature is varied. Which graph shows the variation of pressure of the gas with the temperature in degrees Celsius? So it's an ideal gas, so we will first think about the ideal gas equation only. PV is equal to nRT. Now it is given that the volume is constant, N is constant, and R is constant. So when every else thing is constant in equation and there are only two variables, then we can very well say that pressure is directly proportional to T, and it is T raised to power 1. So it is a linear variation completely. So that's why it is going to be a straight line first of all. Now this is out of our option now. Another thing to be noted here is that if pressure is on y-axis and this is on x-axis, you can see that the coefficient is positive. So it is going to be having a positive slope. So it cannot have a negative slope. So pressure is not reducing with temperature. See, it's directly proportional. More is the temperature, more is the pressure. So D is also out of the question now. So we are left with A and C now. Okay, so what is the difference in A and C? The pressure and the temperature. So okay, this is degree C. Yes. Now the another thing that we need to consider here is that on axis it is degree C, it's not Kelvin. So if we extrapolate this line, it is going to pass through the origin somewhat, isn't it? But it cannot pass through origin. Like if it is passing through origin, so at 0 degree the pressure is becoming 0 degree. Now the temperature is not in absolute terms, but the pressure is in absolute term. Pressure will become zero only at 0 Kelvin. So if we're talking about degrees C's, so it is not a zero, it is like 273 Kelvin. So pressure can nowhere be near zero. So it has to cut this axis at some positive intercept. So definitely A is going to be the correct answer, C will be wrong because it cannot pass through origin. Simple. Because at 0 degree centigrade, the pressure of the gas cannot be zero in absolute terms. That is why A will be the correct answer and C is wrong. I hope you understand. Whenever we write these capital letters P, V, and T, they are in absolute terms. The scale has to start from zero. And if one thing becomes zero, everything becomes zero. So at absolute zero, volume of the gas is zero, pressure of the gas is zero. That is why A is going to be the answer. So my dear students, this is Professor Varun. Please subscribe to the YouTube channel. All the best.